Lovely day. Let's go ahead and go over the review for this, not the second 9 weeks, but the second, third week cycle that we're in. And what we're going to do is that now one of the biggest things I would like for you to do before you really watch step by step what I'm doing is for you to try each problem. So go ahead and please pause the video and try each of these problems. And when you get stuck or want to verify if you did it right, that's when you continue playing the video. Because if you just go ahead and just watch the video without trying any of it, it's kind of like watching the TV. You'll remember some parts of it, but as far as recreating certain scripts, it may not necessarily all work out. Now, let's go ahead and go through this first problem. Now, this one, the question one, they're asking us to graph the piecewise function on the grid provided below. Identify the domain, range, and intercepts of the piecewise function. Now, first of all, when we go to piecewise, I'll have three different functions that are just pieces of each other. What do I mean? Now, first of all, I'll have this line that will exist only from -1 this way, so I'll make a highlighted mark. So it's going to be going that way. I'll have another, actually an absolute value that's going to look like a V. That is, it's only going to exist in a very small piece of this graph from there to there. And lastly, I'll have another small piece of a graph, which is this part right here, that exists only from the section 2 to 5. So in essence, I'm going to have three different graphs. They're going to look short, except for one, which is that line, the yellow one, that goes on forever. And then from there, I'll have my piecewise function. Let's go ahead and start graphing the first line. And the first line, you know what, you could very easily get your calculator and get points from. So like, for example, I know that most of y'all, let me go ahead and pull up a calculator just so I could have it handy as well. But like the first one, you see where it says 2x plus 8? That 2x plus 8, a lot of times when I'm up here, I'll graph it just by hand because for me it's easier just to do that. It's quicker for me. But I know some of y'all like to verify in the calculator. Let me clear this calculator and go to y equals. I'll type in 2x plus 8. And after that, I'll get a graph. And now, in essence, I'm just going to get this piece here, a small piece. When I pull up the table, I think I'm looking for the negative numbers. So like a -1, which is going to be 6. I'll have an open circle right at that spot. So here, actually -1, what's a 6? I'll actually have an open circle like this. And then from there, I'm going to go down, I'm going to do slope, which is +2, which is rise over run up to over 1, so it means go down to and go down and over to the left. So I'll have this, a generation of these points. You get these, I'm doing this by slope of rise over run, but you could very easily do this also getting points from the calculator. But this line is going to continue like that forever that way. Now the absolute value, something similar. You could go ahead and actually do it in your calculator. I know from absolute values that I could easily know that they're going to run like this. I'll start here at the origin because it's going to cross 0, 0. At -1, it's included, so we're going to put a solid dot to say included. The reason why it's included is because of that inequality with the line underneath. It means it's equal to it. Now at 2, though, it's not included, so I'll have an open circle. But this piece of the graph will look like this. Go ahead and connect that all the way. Lovely. And lastly, we're going to go ahead and just do the piece from 2 to 5. Now I have x minus 2, which means I have an intercept here at the y-axis. So what I'm going to do is I'm just going to go ahead and just follow that. Again, you can use your calculator if you really wanted to make sure about the points. But you will have then a slope of 1 for this piece here, and they're included on both sides. So that means you see how it did two big filled-in circles? Because that means that they're included at those very end points of our domain for that point. Now let's talk about the domain of the whole thing. Now what I'm going to do is I'm going to go ahead and look at the x-axis. So what you could do is, like, imagine if I'm looking. Okay, I know that it's going to exist from -infinity. So from this one, I will go from -infinity because of that line. And I just got to see if there's a break. There's not a break at -1, there's not a break at 2, and there's not a break at 5, but it ends at 5. And it's including 5, so I'm going to go ahead and do a closed-in bracket. Remember, this means included when you're writing down domains. Now, this is the only way to write it? No. You can go ahead and very easily do it like this. And that would mean the same thing as on top. So do not just be stuck on one part. If you feel more comfortable writing an interval notation, do that. So let's go ahead and I did set notation up there. Let's talk about range. Now with range in itself, I don't have anything exist above 6, and actually 6 is not included. So from these, I'm going to use actually just a Y. I'm just going to say everything less than 6. There is no breaks in my range because everywhere there is a point. And it's guaranteed in different places, but mostly because of that 2x plus 8. Now, as far as intercepts, let's go ahead and show those in red. Intercept here, here, and here. So I have 3 points. They're specifically 4, 0. And I'm looking for both x and y intercepts. When they just say intercepts, you have to assume that it's going to be both. 0, 0, and then also 2, 0. Okay, fantastic. Let's go ahead and move on to the next problem. Again, try this problem first by yourself, and then watch what I do. You can pause the video if you like now. But let's go ahead and now move forward to what the answer to this problem is. And it says, write a function whose graph of y is square root of x, but is shifted 5 units down and compressed vertically by a factor of 3. Now with this one, I'll take you back to our general equation. A cx minus h plus k. Now, shifting down means I'm going to use this. We'll call this a shift down. And compress. Now, the important word here is vertically. This compresses or stretches vertically. So this is the part that when you're talking about compression or stretching is being caused. Now, in order to compress something by a factor of 3, that means for this one, I'll have an A here, which is going to be my 3, and then a plus. Actually, it wants to be shifted down, right? So that's not going to be a plus. It's going to be a minus. It's going to be a minus 3 there. I mean minus 5. That's what the, or I should probably put minus k since I put the other one in A. But in not our case, the answer would be this. This is cause compression of a factor of 3, the square root of x, minus 5. This causes a shift down. So in itself, I went ahead and answered that question. Now let's go ahead and now do question 3. Again, pause the video if you haven't yet tried it. Now name the parent function associated with the following function. Also describe each of the transformations you'd like to make to the parent function to graph the equation. So they want us to put in words what's going to happen. Now first of all, the parent function of this is the absolute value. And if you are completely lost of what to do, you could also graph this one to see everything that happens. Now I can tell you automatically a couple of things are going to happen because the A is negative. It means it's going to be reflected on the x-axis. That's one thing that's going to occur. Since your A is a fraction, which means it's less than 1 but greater than 0, means that it's going to be stretched vertically. And because of my h being positive, means it's going to be shifted to the left. By 2 units. Ooh, let me write that down, units. And because my k is negative, means it's going to be shifted down by 5 units. Shifted down 5 units. Alright, great. Alright, so there we go. And that's what happens in that case. Now let's go ahead and move on to the next problem. Okay, now this next problem, problem 4, I want you to graph each of the following functions using the techniques of shifting, compressing, stretching, or reflecting. Start by graphing the parent function and explain the transformations made to create the new graph. Now the parent function on this one is just simply x squared, which means I'll have an x squared graph. Now I'm going to draw the parent function first, and I'll make it in black. 2, 4. That way. Okay, lovely. Now let's go ahead and talk about the next one, which is the transformation that's going to occur. Now, a couple of things that I'm going to do. First of all, this is going to shift to the right by 1 unit. And that happens because of this value right here, the -1. And then after that, I will have a compression to compressed by 2. So that's going to have specifically to the y value. So what does that mean? That means this. That means that when I graph this, I'll actually end up having this shifted over to the right. That means that now I'll have a point there. And then instead of having my value being at 1, I'll have it at 2 here. So like in this case, you see where that point is? This is what's going to happen when you compress it. And then this one over here is going to double as well. So it's going to just shoot up way up there like this. What's going to happen with the compression. And if you want to verify that, you're always welcome to type this in your calculator. Oh, hold on a second. Let me clear the ink. Got the ink going on this calculator. So y equals, and let's type both of them in. X squared parent function, and the other one was 2 x minus 1 squared. And you'll hit graph, and you'll see something similar to what I did. And you see the compression right in there. So that is exactly what is occurring in our case. We are having, how do you put it? We're experiencing this kind of equation happening for us. Now let's go ahead and actually move to the next problem, which means that in our case, let's see the y values. Hold on, I'm just looking at something right here. 0, yeah, that's exactly what's going to occur. Now let's move on to the next problem and compare that. All right, so now what is going on with number 5? Number 5, now the parent function on this is going to be just absolute value. So with this one, I'm going to go ahead and write down the parent function. I'm going to graph it. Absolute value is pretty easy to graph. It's kind of like a linear equation, but so we have this. So it looks like a V. There we go. Parent function graph. Now let's talk about the transformation. A couple of things are going on with this. First of all, we're going to have a reflection on the x-axis. We're also going to have a stretch vertically. It's going to be a third. We're going to have a shift to the left by 3 units. And we're also going to have a shift upwards by 4 units. Okay, so first of all, let me go ahead and focus on this point right here, which is the origin. We're going to first of all move this point 3 units to the left and shift it up 4 units. So that means that I'm really going to start here. And then my V is going to be upside down because it got reflected over the x-axis, which means in this case, I'm going to have, and it's also going to be by a third. So like what it means by that is that instead of, it's going to look very compressed. So instead of my point would normally being there, I'll have that, and then that. And something similar over here. Where this is where originally would have been 1, 1, it would be just now 1, a third. And what I mean is like this point here. Like when we're talking about the stretch vertically, instead of being 1 and then the y being 1, it would be 1 and 1/3. But inferior in this kind of manner. So you will have something like this. And if you want, you can go ahead and verify that on your calculator, and that should assist you as far as coming up with something. Okay, great. Now let's go ahead and now move on to this one, number 6. This is a commission earned by a real estate broker on a home sale can be modeled by T. So you got this equation, and it says determine the amount of commission earned for the sale of the house at $450,000. Now, first of all, I have to look at the domain to know which one would that fit in. So when I look at the domain on this one, I'll find out that this one fits exactly right in here, which means I'm going to use that equation to solve the problem. So let's go ahead and do that, and let's use the equation. So I have to figure out 0.03 times 450,000 plus 2,000. Excellent. So all you got to do is just bring out a calculator and see what that comes out. You know what? I have quite a few things here, so I'm gonna reduce the view on this because I want to make sure that I have see part of that board there. So let's go ahead and put 0.03 times 450,000, and let's add 2,000. Okay, there it is. So that means commission made is about 15,500. That's the commission made. Okay. Now it says right here, question B says, how much more would the real estate broker make with the sale of the house worth 500,000? Now this right here is actually this question is kind of uncommon as far as the application in real life, because most of the time when the house prices go up, typically you get paid. Now you don't get paid less commission, but it does lend itself that you're not going to make as much money as you would be with like an average price house. Now let's go into details about this and see what that would mean. That means that in this case, that one, forgot to write the $500,000 highlighted house. Now I'm hoping y'all are pausing this video, and when I mean don't pause it now, but pause it, try it before I actually do the problem up here. If you haven't done that, do that now. Now let's go ahead and try this, which means that the setup on this one's going to be pretty simple. It's going to be 0.05 times 500,000. So it comes out being like 25,000. So I'm going to subtract the 15,500. That was originally the amount that I got from 450,000. So it should be 25,000. 25,000 minus 15,500, which comes out being roughly 9,500. Not roughly, it is 9,500. So there's your answer for that one. Now let's go ahead and move on to the next problem, and we'll start answering these. So with this one, it says for the given functions f and g, find the fog of s, find the gof of x, and determine the domain of each new function. So it wants to just for us to determine the domain of each new function on this one. Alright, fantastic. Let's go ahead and start doing the fog first of this one. So I want to go ahead and clear this up board just a little bit, and let's begin that process for this first one. Now the fog, what does it mean? Now you got to make sure you memorize this. Fog of x is really f of g of x. And with that, we're going to go ahead and take the g of x, which is this one, and put it right in here. So you can draw an arrow to kind of see that. So it's going to look like this. I'm going to have 3, 5 over x minus 2. Which I probably shouldn't put a parentheses there just because it's not really needed. And let's make sure that we finish this up, so plus 4. And now let's go. Now, one thing that's important before we even begin these, you got to make sure that you define the domains for each one. Because remember, your final domain, like this one, is all real numbers. Your final domain is going to contain f of x, g of x, and the new composition. This one's domain was all real numbers x, such that x does not equal 2. So there you go. Now, let's continue with this part. Fog. Okay, so this comes out being then 15 over x minus 2, and all I did is just distribute this plus 4. Now, I'm not done because I need to put this as a common denominator between the 4 and this here. So in order to do that, and I'll make it in red so you can see this. You can see the change, x minus 2, x minus 2, and then from there, I'll be able to get a common denominator, which is x minus 2. Now I'll put 15. I'm going to draw arrows here because I'm going to show that that's a 4x in that arrow, and in this arrow it's a minus 8. So that means my ending answer means that this term and this term are going to combine, give me 4x plus 7. It's over x minus 2, which means that my domain is, well, that's my answer, 4x plus x minus 2. And my domain is going to still be my original one of the ones, my g of x one, which is x cannot equal 2. So there's not really a change there. No, nothing really new to add. But now let's go ahead and now talk about the next one, which is now the GOF. Reverse. I'm going to go ahead and erase all this. Again, you try it. Make sure you know what you're doing before you move forward and do what I'm doing here, because that's how you get the maximum benefit of this. Now let's, on this one, the GOF of x is really the g of f of x, which means in this case I'm going to take this and put it right in here. It's going to look like this. 5 over 3x plus 4 minus 2. These two will combine. 5 over 3x plus 2. Which means that my domain on this one's going to be slightly different. I'm going to have 3x plus 2 is equal to 0. Which means minus 2 minus 2. 3x is equal to negative 2 divided by 3 divided by 3. X is equal to negative 2/3. Which means that in our case, I'll have my GOF is first of all that 5. I think it's 5 over 3x plus 2. It is 5. 3x plus 2. And my domain is going to be two things. It's going to be the x such that x cannot equal 2, and also negative 2/3. And that's how we get the answer for that one. Okay, fantastic. Let's go ahead and move on to the next one. We're going to do the same thing with this one, fog of this one. And so let's perform that too. Again, try before I do it. Now the fog of x on this one means I'm going to do then this in here. It's going to look like this. Square root of x squared plus 3 minus 1, which means I'll get the square root of x squared plus 2. Now, we didn't, domain needs to be stated in the original functions. This one's x such that x is greater than or equal to 1. And this one is domain is all real numbers. So now with this one right here, this cannot really be simplified anymore, which means that my fog is really then x squared plus 2, and my domain is going to just be my original domain. In this case, which is going to be x such that x is greater than or equal to 1. And there we go. Now let's do the reverse, which is GOF. And let me erase so we could go ahead and do that part. Erase this and erase this. I'm going to get restarted with the idea. Now, first of all, the idea on this one means I'm going to take this and put it right in there. So let me write down first the GOF of x. It's going to be the g of f of x, which means that I really have that substitution where you saw those circles in red, x minus 1 squared plus 3. Now the squares will cancel each other out. X minus 1 plus 3, which means I have x plus 2. X plus 2. Domain is just going to be my original domain restriction, this one as well. Domain will be x such that x is greater than or equal to 1. And there we go. Fantastic. Let's go ahead and move on to the next one so we could go ahead and see another problem. Again, you should try these first before we move forward. Before you actually will look at this video. So if you want, pause the video. Now let's go ahead and make the determination it's 1-to-1. Now for 1-to-1, you got to make sure it passes two tests. Horizontal line test, vertical line test. Now this is a parabola, so I know automatically, even though it passes a vertical line, it will fail at the horizontal. So that means, therefore, it's not one-to-one because of that failure with the horizontal. Now, how do you find its inverse? Well, first of all, we're going to have to do the inverse part. We're going to switch x's and y's. So x and y will switch places, and we solve for y. And we also have to state the domain of f and find its range using the inverse of it, which means that in my case, I'm finding the domain for this. Like the domain, my answer, they want two things. They want the domain of the original function. And whatever the domain of the inverse is, it's going to be the range of this function as well. So this one's x, such that x is greater than or equal to 0 in our case. And so the range of this function will be whatever the domain is. Now, I'm saying that in words, but in shorthand, let me write down both of these notations to kind of explicitly say what I'm talking about. Okay, the domain of this one is really the range of my inverse, and the domain of my inverse is going to be this. So this is what they want you to do. They want you to use this to find this. That's what they're saying. So that's the reason why I still have r there with nothing written. Now, put this here like this, and let me go back to find the inverse of this. Now I'll switch x's and y's, so I'll have y squared plus 16. To solve for y, I'm going to do my step process, minus 16, x minus 16 is equal to y squared. From there, I'll take the square root of it. Y is equal to the square root of x minus 16, which means that in this one, the domain on this is right. Well, actually, I could write here. F of inverse x, domain on it, is really x such that x is greater than or equal to 16. And that's the range. The range is going to be y such that y is greater than or equal to 16. And the reason being is because of this idea. We solve here, which I'll point out with a highlighter. Here, this idea. The domain of the inverse will be the range of my original one. And it is. So fantastic. We have that one down. Now, I won't do number 10. 10 is somewhat simple. It is one-to-one because it does match the horizontal and vertical line test. But go ahead and practice what we did here. And I do want to move on to one of the other ones because I want to say they're a little bit more difficult for y'all. And now this one, I want you to verify their inverses. So why don't we do that? Why don't we verify their inverses? And I'll just do one of these. And you could do and it should give you enough skill to do the other ones. Now, let's go ahead. Remember, the idea here is this. The inverses are going to prove this. It's going to prove that this idea that you're going to x there and x there. So let's do the first one, which means I'm going to take this and substitute right in there. The fog of x. So let me do the parentheses cube root of x plus 8 cubed minus 8. Okay, excellent. That cancels. X plus 8 minus 8 means I have x. So that one checks out. Now let's do the other way around. Let's do the goth. Now with the goth of x, it's essential that we go ahead and are able to do the same thing we did, but with the reverse. So we erase this and put it into detail. And now we're taking this and putting it right in here. So what does that mean? That means that we get this. That means we're now going to go ahead and do the cube root x cubed minus 8 plus 8, which means that, and in reality, I really didn't need the parentheses. Ooh, a little too much there. I'll go back and rewrite. But really, what I was trying to do is just show that no longer parentheses is needed there, so those are going to cancel. And you're going to be left with the cube root of x cubed. Those cancel, so that means you got x, and you have the verification showing that the goth of x is also the inverse. So since both of them equal x, That means they're inverses of each other. Fantastic. All right, let's go ahead and, well, you know what? I might have time just to do one more. Let me see which one of these might be the, this one might be a little difficult for people because there's going to be quite a few mathematical computations in this one. Let's see how the other one was, the other one we left blank. You know what? I would say that if I had to go back to one of them, I'd go back to this one. Because I want to see, I could say that a lot of people will have difficulty now. This one should be 1-to-1. But I want to go through the inverse of this, and if that's the last thing I showed you. Now, to find the inverse, I'm switching x and y. So let's go ahead and do x and y switch. Means that this used to be y. It's now going to be x. 2y minus 3 over y plus 4. Anytime you're confronted with this kind of problem, it's essential to make sure we're trying to isolate y. So I can't have it as a denominator. So the first thing I'm going to do is work on that part. The way I do that is that I go ahead and do y plus 4 on both sides. I multiply both sides. And that'll give me the answer or the ability to get it out of the denominator. I will distribute this part of it here. So I end up with xy plus 4x is equal to 2y minus 3. Now since I'm trying to isolate y, I'm going to do two things. Remove the 3 on this side. So I'll end up with xy plus 4x plus 3 equal to 2y. And then my goal is I want to get just isolation of 1y. So if I move this xy on the other side, I'll give the ability to factor out this y you see here. So let's go ahead and do that. So I end up with 4x plus 3 is equal to 2 minus x with my y factored out. Now I'm going to get the y isolated by dividing this binomial out of the way. And I'll end up then now with the inverse, which is y is 4x plus 3 all over 2 minus x. So that is my, not final answer because I still need to define the domain. Now remember the domain restriction of this one was originally x such that x could not equal -4. And on the range will be whatever this is. So the range, and I'm getting the range actually from this answer right here. Because whatever the domain is for that one, just like the one we did before, it's going to be the range for the original, the inverse of it. So actually, you know what I should do on this one so we won't be confused? Is rewrite that as f inverse of x. It's no longer y, it's now the inverse of it. So now, the domain of this one is x, such that x cannot equal +2. So there's part of my answer here, the one I circled, and also here, as far as stating the domain and range of the original function, and also stating the inverse. Okay, great. And I wish you the best of luck on tomorrow's test. Thank you.